Somewhere in the depths of the constellation Canes Venatici stretches an elongated, fractured structure of light and gas known as the Whale Galaxy. She doesn't look calm. There is no perfect symmetry of spirals or a smooth disk in its shape. Instead, there is a tense, elongated line, like a gigantic stream of matter frozen in motion, but still living with its inner storm. The light of its billions of stars is stretched along a thin disk, and around it spreads an invisible but observable shell of hot gas that extends far beyond the visible body of the galaxy. The Whale Galaxy, also known as NGC 4631, is one of the most dramatic systems in the nearest part of space. Its shape resembles an elongated wedge in which the density of matter is uneven, and the distribution of star clusters creates a sense of constant internal motion. Inside this gigantic formation, processes take place that cannot be observed on a static scale. Everything here is in a state of long, slow evolution, stretched over billions of years. Along the central axis of the galaxy, the bulk of the stellar matter is concentrated. New stars are born here. Dense clouds of interstellar gas and dust are formed, which are gradually compressed under the influence of gravity. These clouds become the cradles of future star systems, where pressure and temperature reach levels that trigger thermonuclear reactions. Each new birth of a star changes the local structure of space, adding new points of radiation to the already existing light flux. The Whale Galaxy is not an isolated system. Next to it is a smaller satellite galaxy, NGC 4627, which exerts a gravitational influence on it. This interaction does not lead to destruction, but creates a complex dynamic in which both systems exchange flows of matter. Gravitational forces stretch the gas structures, forming long tails and elongated clouds that extend far into intergalactic space. These flows become traces of interaction, fixed in the very fabric of the cosmos. The outer regions of the Cetus Galaxy are surrounded by a vast halo of hot gas. This halo does not emit visible light directly, but appears in the X-ray range. Its temperature reaches millions of degrees, which indicates powerful energy processes taking place inside the system. This gas does not remain static, but rises above the galactic disk, forming vertical structures that extend into the cosmic void. Inside the galactic disk, the constant movement of matter continues. Gas clouds collide, compress, tear apart, and reunite. In these processes, massive stars are born, which live short but extremely bright lives. Their radiation forms ultraviolet regions, ionizing the surrounding gas and creating glowing nebulae. These regions become markers of active star-forming zones, where energy is released on scales comparable to entire star clusters. Some of the massive stars end their lives with supernova explosions. These events are not uncommon in such active galaxies. Each such explosion ejects shock waves into space that compress nearby clouds of gas, sometimes triggering new star formation processes. Thus, the death of one star becomes the impetus for the birth of many others. The Whale Galaxy has a complex magnetic structure. Magnetic fields permeate its disk and extend far into the halo. These fields affect the motion of charged particles by directing them along lines of intensity. As a result, vertical streams of cosmic rays are formed, which rise above the galactic plane. These flows create an invisible but powerful structure of energy exchange between the internal and external regions of the system. Particular attention in the observations of this galaxy is attracted by its central region, where the density of matter is much higher than in the peripheral zones. Here, the processes of gas compression occur especially intensively. Clouds collide at high speeds, forming complex vortex structures. These areas become sources of powerful infrared radiation, hidden behind dense layers of dust. Dust plays an important role in the Cetus Galaxy. It absorbs some of the radiation from stars and re-emits it at longer wavelengths. Thanks to this, the galaxy looks much brighter in the infrared than in the optical one. The dust structures form a complex network that runs through the entire disk, linking individual stellar regions into a single system. Gravitational interaction with a nearby galaxy causes the disk of the Cetus Galaxy to remain deformed. It does not take the shape of a perfect circle or a symmetrical spiral. Instead, it is elongated and curved, as if it is constantly under the influence of tensile forces. These deformations are not destructive. They are part of the natural evolution of the system, in which interaction with the environment determines its shape. Inside this elongated disk, the cycle of stellar life continues. Old stars gradually lose their energy, moving into the late stages of evolution. They shed their outer shells, enriching the interstellar medium with heavy elements. These elements become the building blocks for new generations of stars and planetary systems. Thus, matter in the galaxy is constantly being recycled, changing from one form to another. The Whale Galaxy contains a significant amount of dark matter, which does not emit light and does not interact with electromagnetic radiation directly. Its presence is determined by gravitational effects. It is dark matter that holds the galaxy together, preventing it from disintegrating under the influence of rotation. It forms an invisible framework within which visible matter moves. In X-ray observations, the Cetus Galaxy manifests itself as a source of scattered radiation emanating from its halo. This radiation is associated with hot gas that was ejected from the disk as a result of stellar explosions and powerful energy processes. The gas rises above the plane of the galaxy, forming extended structures that gradually dissipate in the intergalactic medium. The dynamics of this system show that the galaxy is not a static object. It is constantly changing, although these changes occur on timescales that are inaccessible to direct perception. Gravitational interactions, stellar explosions, gas flows, and magnetic fields create a complex network of processes in which each event affects the others. The Whale Galaxy continues its rotation around its own center of mass. This rotation is uneven. The inner regions move faster than the outer ones. Such a difference in velocities leads to stretching of the structure and the formation of spiral and wave-like distortions. These distortions intensify the mixing of gas and stimulate new bursts of star formation. Its extended form hides the history of long-term interaction with the surrounding outer space. Every deformation, every flow of gas, every star cluster is the result of multi-million and billion-dollar processes that continue today. The Kit Galaxy remains a living system on a cosmic scale, where energy and matter are constantly moving from one state to another. In its depths, the movement of matter, the formation of structures, the destruction of old stars, and the birth of new ones continue. The light of its stars passes through space, carrying information about the processes taking place inside. And although the distances between the individual elements are enormous, everything within this system is connected by gravity, radiation, and energy flows, which form a single cosmic organism that continues its development in an endless flow of time. Within this cosmic stream of the Cetus Galaxy, processes continue to take place that gradually change its internal structure, although outwardly these changes are almost imperceptible on short timescales. The gas fibers stretched along the disk are slowly displaced by gravitational waves, creating complex areas of compression and rarefaction. In these zones, matter gathers into dense clumps, which eventually become future centers of star formation, and there are voids nearby where matter is temporarily rarefied and seems to recede, giving way to dynamic equilibrium. In the densest areas, the formation of massive stellar cores continues. These objects do not exist in a stable state for a long time. Their internal energy quickly reaches the limit, after which intense radiation and ejection of matter begins. The surrounding space responds to this radiation by expanding and heating the gas, forming bubble-like structures that grow and connect with neighboring regions, creating chains of active zones. These chains stretch along the disk of the galaxy, enhancing its elongated shape and maintaining a constant redistribution of matter. Gradually, regions are forming inside the Cetus Galaxy, where the density of stars becomes higher than average. These clusters are not static. They continue to move within the overall rotation of the system, sometimes approaching each other, sometimes diverging under the influence of gravitational perturbations. Such interactions lead to a redistribution of the orbits of stars and a change in the local structure of the disk. The result is a complex network of streams in which each star follows its own path, but at the same time obeys the general gravitational field of the entire galaxy. The outer regions of the system gradually lose some of their substance. Gas tails, stretched far beyond the visible disk, become thinner and more rarefied. However, they do not disappear completely, but continue to exist in the form of extended structures connected to the main galaxy by invisible streams of matter. These streams slowly move into the intergalactic environment, preserving traces of interactions that occurred in the past and recording the history of dynamic changes in the system. In the central part, the accumulation of heavy elements formed as a result of stellar evolution continues. These elements mix with the cold gas, changing its chemical composition and physical properties. Over time, such changes affect the character of future stars, forming differences in their mass, temperature, and lifespan. Thus, each new stellar generation is different from the previous one, even if it is formed in the same region of space. Hidden compression processes take place inside dense dust clouds. These clouds absorb radiation from surrounding stars, keeping them in cold and dark zones where matter gradually condenses. As the density increases, the gravitational pressure increases, and at some point, a rapid contraction begins, leading to the formation of protostellar objects. These objects are surrounded by rotating disks of matter, from which star systems with residual dust and gas structures can later form. The rotation of the Cetus Galaxy remains a key factor in determining its shape. The differences in rotational speed between the inner and outer regions create a constant stretch of the structure. This stretching amplifies pre-existing deformations, giving the galaxy its characteristic elongated silhouette. Within this rotation, density waves arise that move across the disk, intensifying or weakening star formation processes in different zones. The energy processes inside the galaxy are accompanied by a constant exchange of radiation between its various layers. Photon fluxes born in hot regions pass through dust structures, partially absorbed and re-emitted in a longer wavelength range. This creates a complex pattern of energy distribution, in which different parts of the galaxy manifest differently depending on the wavelength of the observation. In some ranges, dense clusters of stars are visible. In others, extended gas structures. And in still others, hot regions of active star formation. Over time, individual stars leave the active regions and move to more stable areas of the disk.
These stars continue their motion around the center of the galaxy, gradually dispersing throughout the system. Their orbits become more elongated and chaotic, especially after gravitational interactions with other massive objects. Such changes form a complex dynamic picture in which there is no strict order, but an overall balance is maintained. In the Cetus Galaxy, the accumulation and redistribution of energy associated with the birth and death of stars continues. Each supernova explosion contributes to the enrichment of the environment by creating shock waves that travel over vast distances. These waves compress gas clouds, sometimes initiating new cycles of star system formation. In this way, destruction becomes part of the process of renewal of the structure, maintaining a continuous circulation of matter. In the distant regions of the galaxy, the movement of matter becomes calmer but does not stop completely. It is dominated by rarefied clouds of gas and rare stars that move in stable orbits. However, even in these zones, there are weak gravitational perturbations coming from the central regions of the system. These perturbations gradually change the distribution of matter, albeit on extremely long timescales. The magnetic fields that permeate the entire structure of the Cetus Galaxy create an additional layer of interactions. They direct the movement of charged particles, forming thin filaments and structures that extend above and below the galactic disk. These filaments connect different areas of the system, creating an invisible network through which energy and particles are transferred. As a result, the galaxy acquires additional connectivity that goes beyond the purely gravitational interaction. Within these processes, a gradual change in the general form of the system continues. Deformations caused by interaction with neighboring structures are slowly redistributed throughout the disk. Some areas become denser, others more rarefied, but the overall balance is maintained due to the action of the dark halo surrounding the entire system. This halo, made of invisible matter, holds stars and gas within the galaxy, forming a stable gravitational base. Gradually, new regions of stability are forming inside the Cetus Galaxy, where the movement of matter becomes more organized. These zones do not remain permanent. They shift, deform, and disappear, giving way to new structures. Everything within the system is subject to a long process of redistribution in which there is no final state, but only continuous change. And in this continuous change, the main feature of the Cetus Galaxy is preserved: its ability to simultaneously destroy and create, stretch and compress, scatter and concentrate matter, keeping it all in a single rotating flow that continues through billions of years of cosmic evolution. Within this rotating stream of the Whale Galaxy, new levels of complexity continue to form, which become noticeable only when observed at different emission ranges. What appears to be a relatively quiet patch in optical light reveals a very different picture in radio or X-rays. Intertwined structures of hot gas, elongated magnetic lines, and regions of active interaction where energy is continuously transitioning from one state to another. The gas in the galactic disk no longer exists as a single medium. It is divided into many phases: cold, dense clouds, warm, intermediate regions, and hot ionized zones that fill the space between star clusters. These phases are not separated from each other by rigid boundaries. They flow, mix, and separate again under the influence of shock waves, gravity, and radiation. The result is a constantly changing structure in which there are no fixed forms, but only transitional states of matter. In the central part of the Cetus Galaxy, the accumulation of energy associated with the movement of dense stellar streams continues. Here, the orbits of objects become increasingly intertwined, creating complex trajectories that intersect and diverge under the influence of gravitational perturbations. These intersections do not lead to the destruction of the system, but change the distribution of velocities and density, gradually redistributing matter within the inner disk. Dust structures passing through the entire galaxy play the role of a kind of filter through which radiation passes. In these corridors, conditions become especially favorable for the slow contraction of matter, which leads to the formation of new stellar cells hidden from direct observation in the optical range. In the distant parts of the disk, the gradual dispersion of matter continues. However, even there, a weak structure associated with the overall rotation of the system remains. Stars on the periphery move in orbits that deviate further and further from the plane of the disk, creating a slight three-dimensional blurring of shape. These deviations increase over time, especially under the influence of gravitational interactions with neighboring objects. The Cetus Galaxy continues to interact with its surroundings, not only through gravity, but also through streams of gas that extend beyond its visible body. These flows form extended structures that gradually lose density but do not disappear completely. They become part of the intergalactic environment, preserving traces of processes that took place inside the galaxy millions of years ago. Inside star clusters, the evolution of massive luminaries continues. Their life cycles pass quickly by cosmic standards, and each completion of such a cycle is accompanied by a powerful release of energy. These ejections create shock fronts that propagate through the surrounding gas, compressing it and initiating new waves of star formation. Thus, energy is not lost, but redistributed, passing into new forms of structure. The galaxy's magnetic field becomes more complex as it moves away from the center. It forms arc-shaped lines that rise above the disk and descend again, creating a three-dimensional network of interactions. Charged particles move along these lines, forming streams that connect different regions of the system. These streams play an important role in the distribution of energy between the inner and outer layers of the galaxy. Over time, regions arise in the Cetus Galaxy, where processes stabilize for relatively long periods. In these zones, star formation slows down and gas clouds move to a more stable state. However, this stability is not final. It is only a temporary phase in a general cycle of matter redistribution that has been going on for billions of years. In other areas, on the contrary, there is an increase in activity. There, gas streams collide at an increased rate, creating zones of high density and temperature. These regions become centers of intense radiation, where massive stars are formed, which have a strong impact on the environment. Their radiation changes the structure of neighboring clouds, destroying some and initiating the compression of others. Dark matter continues to be the basic framework of the entire system. Its distribution determines the overall dynamics of rotation, keeping the galaxy from disintegrating. Although it does not manifest itself directly, its influence can be traced at all scales, from the movement of individual stars to the overall shape of the disk. Without this invisible component, the structure of the Cetus Galaxy would not be able to maintain its integrity. Inside the galactic halo, the slow movement of hot gas continues, which gradually cools and returns to the disk. This process takes huge time intervals, but it is an important part of the circulation of matter. The gas that has left the active regions is not lost, but returns back, participating in new cycles of star formation.
Over time, the structure of the Cetus Galaxy has become increasingly complex and multi-layered. Regions of high activity and zones of relative rest, dense clusters and rarefied flows, hot and cold phases of matter coexist in it. All of these elements are interconnected through gravity, radiation, and magnetic fields, creating a single dynamic organism. And within this organism, there is an infinite motion, a motion in which there is no final form, no complete state, but only a constant transformation of matter, energy, and structure, which sustains the existence of the galaxy in its continual cosmic evolution. And in this endless stream of transformations, the Cetus Galaxy continues to exist as a single system, held together by a delicate balance between attraction and motion. Matter within it never remains at rest. Cold clouds slowly condense, stars complete their cycles and return elements back to space, and new luminaries light up in the depths of dust nebulae, as if maintaining a continuous rhythm of cosmic breathing. Its elongated shape remains a trace of ancient interactions and ongoing gravitational influences, where every stream of gas and every stellar orbit is woven into the overall structure. Even the calmest areas retain hidden dynamics, waiting for the moment when conditions change again and start new processes. This is how the movement within the Cetus Galaxy continues, with no beginning to distinguish and no end to record, only a continuous evolution of matter, light, and energy, stretched over a scale where time becomes part of the very structure of the cosmos.